Alright, let's look at the homework 3, problem number 8. Alright, so if you read the previous post, you see that the equation we have is a pi y over m quantity squared dy over dt is equal to k times square root of y. Alright, so let's try to, I'll get you guys started. Alright, so first thing I would do is I'm trying to simplify this equation, right? So so you have a pi, so that's just a number, right? Then you have a m squared, that's just a number, right? Then you have a y squared, so you have y squared, and a dy over dt, right? Then if you don't like square root, you can always write it as a y to the 1/2 power. Alright, so I want to put all the y's on the left and maybe all the numbers on the right. So how about this? Divide through by y to the 1/2. Alright, then I'm going to multiply by, say, m squared over pi. Right? That way I can cancel pi over m squared. Alright, so we have y squared divided by y to the 1/2 power would be y to the 2 minus 1/2 is 3/2 power. And I'll still have dy over dt. And this is equal to, right? So you have k. So you have a k m squared over pi. Right? So we have that. Then we can just take the antiderivative. So integral with respect to t. Integral with respect to t. Alright, then you will get, we can cancel dt here and dt there. So antiderivative y to the 3/2 power dy with respect to y would be add 1 to 3/2, so it's a 5/2. And the divide by 5/2 is same thing as multiply by 2/5. Right, so this is just a power rule. And then this is equal to k m squared over pi t plus some constant c. Right, we have that. Then what we want to do is we are going to first multiply by 5/2. You get the y to the 5/2 is equal to, right? So you have, let's see, so that's cancel out. So you have a 5km squared over pi t plus 5 over 2c. Right? But you can see that there's no point of using a complicated expression for a number. So here's a constant. This is a constant. So I'm going to call this guy, say, A. Right? And this guy right here, I'm going to call this guy B. Right? So we have this guy equals AT plus B. Right? So if you want, we want to isolate y, so we can raise both sides to 2/5 power. So I'm gonna maybe I'm gonna go up here. Right? Raise it to 2/5 power. Right? That way y is isolated. Right? Then you have AT plus B. Raise it to the 2/5. Right? So we got that. Then you can use the initial condition, which was y of 0 is initially 16 feet. And 1 hour later, it became 9 feet. Right? That's it. I hope that this was clear.